Okay, so before we get into that, we are going to do something with our calculator. Okay, and I want you to try to get in the habit of doing this anytime that we do anything involving the line of best fit, exponential best fit, linear regression, any sort of best fit. Okay, and that is the following. You're going to take your calculator and we're going to turn on what's called the diagnostics. Now, what the diagnostics are, it's the option, it's the thing in the calculator that's actually going to pull up the r-squared value. Because, I mean, I would want to know if the fit that we're choosing is even a good fit to begin with. And remember, we can get that by looking at the correlation coefficient. Remember, if it's really close to 1, it's a really good fit. So let's go ahead and turn that on. To do that, you're going to hit the following buttons. You're going to hit second 0. Okay, that takes you to the catalog here. Okay, you're going to hit the X little -1 key. Do you see how that's green for D? So go ahead and hit that. And you're going to scroll down until you see diagnostic on. Okay, you see it? Hit enter and then hit enter again and it should say done, meaning, okay, the diagnostics are on. And now that you've turned it on, you won't have to do it again. Okay? And every time that we pull up the line of best fit, it's going to display the r-squared value, which is important. Again, why? Because it's going to determine if our fit is good or not. Okay? So let's look at an example and see how can we do this. All right. Here's a set of data here. It says some scientists believe that global warming is a result of carbon dioxide emissions from fuel consumption. The table below shows world carbon dioxide emissions from 1950 to 1990. According to the scatter plot, what would this data be, a linear or exponential best fit? And then find the best fit equation. Okay? Now, a couple words here. Scatter plot. Okay? The scatter plot is nothing more than just a bunch of dots that have been scattered. I mean, seriously, that's what it is. All right? So based off of that picture, can we get an idea if is it linear or exponential? Okay? Now, first things first. You're going to take this data and we're going to type it into our calculator. Okay? So I'm going to cover it up for a second just to do the left-hand side. And to do that, remember, this was in one of the lessons. You're going to hit Stat, Edit. Now, I've got some stuff in here. So to get rid of that, you're going to highlight L1 and hit Clear, Enter. Never hit Delete. Okay? Go over to L2, Clear, Enter. And some of you guys may not even have to do that. You probably didn't have anything in there. But the first column, you're going to type that in. So 1950, 1955, 1960, 1965, 1970, 1975, 1980, 1985, and 1990. Okay? So again, here's the numbers that we're typing in. Take a moment. Type those in. Okay, I'm going to move it over to the left just so I can get the numbers on the right now. And then you're going to type this into the L2 column. So I've got 6002, 7511, 9475, 11556, 14989, 16961, 19287, 19672, and 22588. And just take your time typing it in because you, like with any math problem, you mess up one little detail and the whole problem is thrown off. Okay? So, you've got your data in here. All right, now what we're going to do is we are going to follow the instructions of what the problem says according to the scatter plot. So, okay, according to the scatter plot, what is this going to do? So to do that, to make a scatter plot based off of these numbers here, you're going to hit second y equals. Okay, this takes you to your plot menu. Hit number 1, we only want to do one plot. And then simply just switch it to on. Okay, and it's going to make a scatter plot for you. Okay, now from here, the only thing that you have to do to get all the points to appear is hit zoom 9. So zoom 9. And you get a scatter plot. And let's talk about this, okay? Is the data, in your guys' opinion, do you think that it's more or less going in a J-type fashion? Or is it, generally speaking, going in a straight line? Because remember, it's the line of best fit. We want the best thing that we can have. So the scatter plot here, I would say, is more linear than it is exponential. So this we know, based off of this, is going to be a linear best fit. Okay? So, and then it says here we need to find the best fit equation. And again, that's in a lesson that we already covered, but let me show you how to do it again. So from here, all you're going to do is you're going to hit Stat, scroll over to Calc, and remember, you've got option number 4 for linear regression, or you've got option number 0 for exponential regression. Well, since we already established it's going to be linear, we're going to choose 4. So 4, and then enter. Okay, and then here it is. This is the data that pops up. Now notice here that we've got r squared and r. Now the r, you're not going to have to worry about that, but it's the r squared. Look at that r squared, y'all. It's 0.98. That is really, really, really close to 1. Okay, it's off by 0.2 points. Okay, 0.02 points. So you need to, I mean, that's a really good best fit. So all you do now, just build your equation. We've got y equals, this is what pops up, ax plus b, where a equals 426.18, and b equals, okay, this is a large number, and yes, you have to write it, 360.95. Okay, and again, if this isn't clear to you, just plug them in. So the answer would be y equals 426.18x minus 825,360.95. And yes, you have to write it out. Okay, and that is the equation that best models this data. Now, I'm not going to ask you to make any predictions with this like we have in the other lessons. This is more or less, can you distinguish what would be the best fit? Okay, so this is it, because the scatter plot, again, what do you hit to see the scatter plot? Zoom 9. There it is. So it's making a straight line. Okay, at least that's the way that the data is moving. Okay, let's look at another one. All right. The table lists the number of population in the state of Arizona from the year 1970 to 1994. Sketch a scatter plot of the data and find out if the data has a positive correlation, negative correlation, or relatively no correlation. So the correlation part, guys, you don't have to worry about that, so ignore that. Okay? But I do want us to figure out, just like we did with the first example, is it linear or exponential? Okay, and then I want the equation. All right, so we're going to go ahead and start typing in our numbers. And remember, to get there, you're going to hit what commands again? Stat, and then enter for edit. Now, I will need to clear out L1, so you're going to highlight L1, clear enter, L2, clear enter. Okay, and start typing. Okay, so L1, we've got 1970, 1980, 1985, 1987, 1988, 1989, 1990, 1991, 92, 93, 94. Okay, and then this one, 1509, 2141, 2529, 2813, 2768, 2962, 3005. Okay, that's the best part also. I was just thinking about making a video like this, because if you did mess up the numbers, you can always pause and then catch up with me. Okay, so just try to take your time writing these in. Now, what am I going to hit to check out the picture? Right, Zoom 9. Do you have to turn your plot back on? Well, no, it should already be on from the last example. So unless you do not want a scatter plot, then you would have to turn it off. But since it's already on, we want to keep it on. So Zoom 9. All right, and what would you say this is? Would you say that this is forming some sort of J, or would you say that this is relatively making a straight line? Okay, and it's actually another linear regression because it is moving, or the data seems to appear sort of in a straight line. If you were to put a ruler or some sort of straight edge on this, most of them would fall on that straight line. So I know that this is a linear function. Okay, so it is linear. We've got that down. Now I just want the equation. So remember, you're going to choose linear regression, not exponential. So stat, calc, 4, enter. Okay, check out the r² value here, 0.99. That's awesome. That's really, really close to 1. So I know that the linear is a best fit. It is a good fit for this. Okay, so now you just write out your equation. So I have here that y is equal to 75.64x, and yes, you have to write this big number out, minus 147567.56. Okay? So if you have any questions on this, just rewind the video. That way you can see, you know, where is it that you're not typing, am I typing it too fast for you? But nevertheless, this is what we're doing. Okay? Let's look at another one. Okay? Same thing, except we're talking about a coffee pot and its brewing times and temperatures. So same song and dance. Is this linear or is this exponential? Okay, and then I want the equation. Okay, so start typing. Again, stat, edit. Okay, to clear a list, you're going to highlight L1, clear enter, L2, clear enter. So here we go, 0, 5, 8, 11, 15, 18, 22, 25, 30. Okay, and then the second column, 179.5, 168.7, 158.1, 149.2, 0.7, 134.4, whoops, 0.5. It's really easy to make a mistake here, so just take your time when you're doing this. Okay. Now, if you still need a few more moments, just pause it. The numbers are right here for you to see. Okay. Now, let's take a look at the scatter plot to see what kind of picture this is going to be. So zoom 9. Okay. And what do you notice about this scatter plot? Would you say that this is relatively more making a line, or would you say it's some sort of J curve? Okay. And hopefully you recognize that this is a J. It's a backwards J, which means that would this represent a growth or a decay? A decay because it's going downward. Okay? So we know it's exponential because it's making that J curve. And now I want the equation of the exponential best fit. So to get that, you're going to hit stat, calc. You're not going to choose 4. 4 will get you linear. You're going to choose, scroll down until you see, it says number 0, but that's exponential regression. Enter, enter. It's thinking. There it goes. All right, and so here it is. So y equals, we've got the A, 171.46, and then B is 0.988. Okay, raised to the x. Now remember, if it's exponential, your variable is going to be where the exponent's going to be. And we'll write that in a few moments. But look at the r squared. The r squared is 0.97 here. That's, again, a really good best fit. Okay, so I mean, it's sort of, you can say, sort of cheating in a sense that you use the scatter plot instead of using the r squared value. But nevertheless, the scatter plot does give you the precise picture of what's going on, whether it be linear or a J curve. Okay, so again, our equation is y is equal to 171.4 times 0.988 raised to the x. Okay, this is the equation that models that data. Okay, So nothing more, guys, than just typing in, looking at a picture, and choosing the correct regression, linear or exponential. Okay, I've got a couple problems for you to try. Okay, and we'll see that in a few moments.